Okay, so here we have a vintage, about mid-1930s vacuum tube radio. It's, well, I'm not sure who it's actually made by. It came in a wooden cabinet, which you'll see now. And basically, it needs a full restoration. I actually got it given to me, so it's really nice. So I need to replace the old power cord. It's old, like, cotton wrapped. I'll be just replacing it with this. Got off an old set-top box, I think. Got a bag of replacement capacitors for it. Won't be using all of them. But it took 4 weeks from China, a whole month, just to get here, so hopefully they won't explode. Okay, now I'll show you the underside of it. It's got an interesting story to tell. Okay, on the underside you can see it's got a bit of damage, especially to those paper capacitors, and that's somehow a mice managed to get into this thing, even though it was full straight up like this. Like, this plate was mounted onto the front of the radio, yet somehow at least one mouse managed to get in here and chew up the capacitors. These are all like 0.1s. They're two filter capacitors, 8 microfarad electrolytics. And this is the rectifier tube. It's an old 4-pin. It's a number 80. The modern day, well, more modern equivalent would be the 5Y3. But yeah, some sort of someone went in here at one stage and replaced most of the resistors and capacitors. Well, all the capacitors, I think, except bar this one down here. And replaced them all with these Ducons. So it's probably from about the mid-1950s. This one's untouched, and these two are like 0.1 microfarad. This is an interesting 25 microfarad at 40 volts. That's probably a original resistor there. And they got it like a dog bone, 40 ohm. It's pretty disgusting. You can see the old cable all cracked and split. It's just tinted garbage. Yeah. So first thing I'll do is make sure the transformer's not shorted. Then I'll replace the power cord and then start recapping. But before I do that, I'll take off the DC high voltage from the rest of the circuit and actually check what the high voltage is at with no load on it, just to make sure that the capacitors don't get a bit upset. It's amazing. From China, all these capacitors, $30. Don't know what how good quality they are, but it'll be interesting. I'll make sure they're not shorted before I put them in, just because better be safe than sorry. You can see this really massive variable tuning capacitor for the tuning circuit. I've never seen one like this. You can actually see the mica wafer in there. You can see the old rubber's gone a bit funny, to say the least. But you got a lot of domino capacitors, which generally don't go bad, but I have got replacements if I need to replace them. So yeah, I'll start checking through things and replace the power cord, and then I'll be back. Okay, so now I've resoldered, well, soldered in the new power cord and adjusted the connections on the front from 200 to 220 to 220 to 250 volt, because here where I am we use 230 volts. And what I've done now is I've pulled out the number 80 rectifier tube, so that's what that looks like. Disconnected the high voltage connections for where the rest of the radio would tap into the high voltage. Here and here. And the number 80 rectifier tube is not plugged in right now. So what I'll do is apply power to the set and make sure there is proper AC voltage and that the transformer is working correctly. I checked the primary and it's not shorted, so anything that happens will either be A, the secondary is shorted, or B, something low voltage is shorted. So I'll just do a quick run for the rest of the filaments and make sure nothing else is shorted, and then we'll test it. So yeah. Okay, so I've checked the filament for the rest of the tubes, and you can see the wire. One of my probes comes out here, goes up here, it's this white wire here to the next, then to the next, then over this bare wire. That's why I've moved it away. You can see that now. There you go, moved it away, goes down to here, and then over to the front of the set, to these globes. Only one of them is connected, as the other three, yeah, it's actually just 3 globes, they've all blown. So we checked the resistance, and it's not a dead short, it's about 40 ohms, which makes sense for all the filaments. So it's not shorted, and I'll only do a quick test. So we'll see if there's voltage here, and then we'll plug the number 80 tube and see if there's high voltage DC. So I've got the meter set on AC, so if it works, the light will go on, which it has. So there's high voltage across these 2 terminals, 782 volts AC. So turn that back off. That transformer is working, no problems. Okay, so now I've plugged in the rectifier tube, and so I'll measure it across here and here. We'll see how many DC volts we get. So we'll just turn it on now. $59, 370. That was pretty quick warm up time. 378 volts DC. Because that warmed up real quick, that rectifier. I guess it's got no load on it. Get a good connection. $377 volts. Yep. There we go. So that works. So now we can turn it off and always unplug this set. Whew, okay. The dangerous part is gone. There's no danger anymore. No capacitors were connected, so there's no high voltage potential left. So everything's working. The rectifier tube is also working, so that's a good sign. That's good. So yeah, now I'll start replacing the capacitors. Okay, I've started replacing the capacitors. I've replaced this electrolytic. Here's the old one. It was a focus. Old Ducon 25 microfarad at 40 volts. I replaced it with a 33 at 50 volts. It's just there. And this resistor here that was connected to it, it's rated for 300 ohms. And I checked it on the multimeter here, and it says it's 302. And that thing's definitely a original from when this thing was made. And I just snipped the capacitor out of here, which is probably the only original capacitor. It's let me just zoom in here a little bit. It says it's a Ducon condenser, non-inductive Chanex 0.1 microfarad 600, rated for 600 volt, and it was tested at 2000. So, and compare that to its modern day replacement, which is only a fraction of the size, which will go straight in here. So yeah, I've starting to get work through all these old capacitors. These ones I haven't worked out with these two go yet, they're the only mysteries. This one here is the same size, like I can't read the value of it, but this is the same size capacitor and it's a 0.01, so they would probably be 0.01s as well. It's not that critical, it'll be alright. So, and these two here are 0.1s as well. So yeah, latest update. Well, I have finished replacing all the capacitors. Finally. I'm not sure exactly if I'm going to keep this like how it is. Probably not. It's just, I just run this lead out. I'll probably just use it like this for testing. It's alright, it won't short out on anything. It's just a pain because you have to run a wire because it's just, the old capacitors are just so much bigger. Now with these little capacitors, they only have short little leads that will not make this distance, and where it has to go is only here. So I have to run a lead, but right now it's midnight, so I'm going to come back to this tomorrow and make some adjustments, and then we may... what will we do next? I guess we have to replace some of these cables. They're beyond what they should be. I'm amazed like this. I didn't realise rubber was a liquid. But it's still isolated. It's not shorting out, so it'll be okay for testing. I don't know if I'll have to touch it. I don't really want to. This will be a nightmare. Stuck to that. There we go. Right, I'm concerned about this coil here. It's got a bit chewed up. So yeah, got some light in there. You can see it's all rusted along this side here because that's probably where any mouse droppings and etc. went and would have rusted it out, and then a couple of these, like here for example, corroded. It's actually pretty surprising. Most of these resistors are within tolerance. I haven't tested them all, and I'm going to finish this, repair this little hack job. It's not really good to do that. Put two resistors in parallel, but I'll fix that. Here's the other filter capacitor. I don't have a soldering iron powerful enough to heat that up here, but I can easily do that. But anyway, they're in, so I'll come back to this tomorrow and hopefully we can continue. And I don't know where these actually go. I haven't worked that out, these two capacitors. At first I actually thought this was from inside this one, but turns out it's not. So I don't know where they connect to. I'll have to look into it. Okay, so it's the following day, and I've already gotten to work. I've replaced this and these two resistors that were out of tolerance, and I fixed or replaced the old filament wire. Falling out of the bin, this old thing that a mouse had eaten through. Made sure all these microcapacitors weren't shorted. That doesn't mean they're good, but at least they're not obviously bad. They can still internally arc when high voltage isn't applied to them, but oh well, I'll find out. Found out, even though it has got these old rubber feet in here, it's not because it wants to be isolated. In fact, it's directly soldered wide in the tuning capacitor, so it's actually just there for some sort of suspension or something a long time ago, so I don't need to bother with that, which is good, because it would have been a nightmare. So yeah, I'm not sure what I'm going to do with this yet, because it is the straight off the rectifier, the rectified DC. I could put a tag strip down like the ones in here, but it's only for the one capacitor. I'll have to think about it. It's good enough for testing though, so I still haven't figured out why these things are here. These two capacitors, I don't know where they go. I don't know, it's really weird. Are they connected? I don't know. Anyway, I've got the rectifier tube still unplugged out of the socket. But when you solder sockets like this, it's really good to take out the vacuum tube if possible, because a lot easier to solder to. You're not heating up, you know, the all the wires inside of the vacuum tube, which is unnecessary. So yeah, that's what it looks like now. These modern capacitors are a lot smaller than these old Ducon paper capacitors and electrolytics. I think this is definitely the only original, if it is in fact an original. That would have been in the set, or maybe these two as well. So maybe three, but other than that, that'd be about it. It was definitely restored in the mid-1950s. And even like these Ducons, it has a date of October 1954 production date, so yeah, definitely not factory. This set is a lot older than 1954, so yeah, we'll just continue on with this, and what I'm going to do next is replace the filament wire that goes along here, along the sides to power all the light bulbs, just because, like, when you have a precarious 80-year-old power lead running through metal like that, it's not nice, so I'm just going to replace that. So yeah, see you in a bit. And I'd just like to point out these filament, well, there's a light bulb pilot light sockets are really interesting. They're a little bit makeshift because they actually have a flat blade screw in there that connects them to ground to complete the circuit. And then on the sides you just got the connection, 6-volt rail running up along and across. So there's 4 lights in total. Only the rest of them burnt out except this one. I'll have to dig through my stash and try and find a few more. Okay, this is the make or break moment, I guess you could call it. I feel as though I've replaced enough components that it'd be safe to turn on for the first time in a long bloody time. So switch is over there. A bit of a hum in the speaker. there's some action. Jesus Christ. Oh, okay. Right. Okay. High voltage makes me nervous. But it seems like as soon as you touch it, it goes into some sort of weird oscillation loop or something like that. So just putting a simple knob on it. It's not going into a feedback loop, because even when I turn the volume down it still does that weird thing. So that's a very weird feedback loop, if that's what it is. I'm not exactly sure. It's picking up noise from the C-file, that's a good thing. Well, that means it's actually picking up signals. I think it's on shortwave at the moment. Don't know why it does that. I don't know. Okay. This is weird. I hate high voltage. See those tubes glowing in there? Oh, some of them. See that? Even through the dirt on that one. That's the rectifier. And the 6v6 there. Looks like it's extremely high hour. I also pulled out, because it looks like that's so high hour, I pulled out another 6v6 so I can pop that in and see what it does. So yeah, I'll fiddle a bit. Okay, so quick update. I have put in this capacitor, attached it to ground finally, bridged this where the phono would connect, so you can, so now the radio section's actually hooked up to the audio section. Done some wiring, and this capacitor here actually gets, it's on the 6v6, it actually gets rid of a lot of the noise I had earlier. Yeah, so it was, there's still something not working, which doesn't surprise me. For a while, I just let it run for a while, and I could turn the volume. The radio section, it's not working correctly yet. What's happening is that the well, it crackles now when I turn the volume control, but it still doesn't receive any signals from a signal generator yet. So I've yet to figure that out. But I've discovered a new problem. It has to do with the 6B6, which is right in here. This one. And you'll hear it. Screech of death when I tap the bloody thing. Well, it doesn't want to do it now. But the volume... Okay. So I'll have to go through this. Ooh, that's new. Yeah, cut the power to that thing. Well, it's been very interesting, this set. Yeah, I'll be back. Okay, so another update. Not a massive amount of time later or anything, but I don't think the 6B6 is bad. You can put your screwdriver on the audio input and it hums as it normally would because it's picking up interference. So the audio section is working just fine, the 6B6 and the 6V6 I think, and the rectifier is working because it's high voltage. So this section is working fine, it's just back here in the radio section that's not. And I have a sneaking suspicion the 6J8G is faulty, which is like the oscillator for all of this. So I have a spare 6J8 that I'm going to put in here and see what happens. If it magically springs to life, that's obviously what the problem was. Alright, I'll go grab it. And in case you didn't believe me that it's a brand new vacuum tube, here it is in the box. To test, break flange of cartnet corners. 6J8GA. There we go. So I'll pop that in, flip this thing over and turn it on. And there's our new 6J8. Looking a lot cleaner than the rest. So let's turn it on and see what it does. I can see the filament lighting up. No difference. Okay, that's not it. Bugger. Well, the 6J8 clearly wasn't the problem, so I put the old one back in, and I've replaced the last suspect that I can think of that would be causing the issue, which is the 6U7. So let's see what it does now with the new 6U7. That's new. Ooh. That is what we had before. That's weird. Okay. I'm gonna figure this out. Alright, I'll be back. Well, it does it. I don't know what is doing that. Yeah, the only thing I can think of that would be doing something like that is, the only thing really left is the old mica postage stamp capacitors. So I'll try replacing them, but as you can see, yeah, there's I don't know. I'll start replacing the mica capacitors and I'll come back and turn it on and see what it does. And if that doesn't fix it, I'll have to pull out the oscilloscope and start probing the thing, so it's going to be a nightmare if it has to get to that, but yeah, sure. Old technology for you. Here's another cool thing. Sounds like a car. Jeez. You'll notice I have this thing hooked up to my signal generator. And there's a very good reason for that. Because I started fiddling and I replaced some of the capacitors underneath and well, it wasn't doing anything, and it was so I was really confused. So I started fiddling with these, the tuning capacitors. And this isn't a slug tuning, this is a capacitor tuning one. Because you can tell because there's two. Anyway, it's on 455 kilohertz. I don't know if that's the correct tuning frequency for this thing or not, because I don't even know who this thing's made by. But if you turn it up, you'll hear it's coming through, and if I adjust the frequency on this, yeah, so that weird distortion that comes through is not gone. You can see it comes back. So it sounds like the capacitors in these things are bad. That's what that sounds like. So yeah, sounds like I'm gonna have to crack open those IF cans and get rid of the old capacitors inside. Yeah, I didn't realise these could get silver mica disease. I assume that's what this is. Yeah, that's very weird. That could happen to a variable capacitor like that. I've never heard of that before. I thought it was only... Oh yeah, and it still does this. Yeah, that's interesting. Yeah. Can't pick up any radio stations though. I'm not in a good area. I don't have a strong, just one strong AM radio station, so you know, I can't really tell you how well it's receiving at the moment, but really it's not receiving well. I've only got 2 distant radio stations that I can pick up on this thing, and that's it. So yeah. Anyway, I think that would be it for this video, because honestly this really is going to lead into a part 2 and maybe even a part 3. This is going to be a pain. Anyway, see you next time. Oh, and if anyone has any idea what this could be, let me know in the comments below. Because this is going to take a while to work out. Anyway, thanks again.